Hello everyone. In this section, I will show you how to design an LED circuit using a DC voltage source. For LED, we're going to use a 3mm LED type manufactured by Vishay LED. So in this section, we'll go through the LED circuit schematic. We will study about the 3mm LED Vishay, the data sheet, the LED circuit design, and we're using a SPICE simulation to demo the circuit. And finally, we learn something about some advantage and disadvantage of this design. So this is an LED circuit, and this is a very simple circuit. We can use a voltage source. In this case, I will use a 5V DC source. Then I will have an LED. This type of LED has a forward drop voltage between 2V to 2.4V, depending on what type of color you're using. And the forward current is 10 mA. And we need a resistor to control or to adjust the amount of current going through this device. LED stands for light emitting diode. So below is a Vishay LED type, and this is the red one. And here you have two pins coming out, the anode and the cathode. You can see that the anode has a long lead coming out here compared to the other pin. In case that you cutting it off, and you cannot determine which side is anode or cathode. So I would look into the metal piece inside here. You see there's a small piece of metal here compared to this side. So the small piece here is the anode side, and the other side is the cathode. And below here is an LED circuit symbol. We have an anode side, which is the plus side, and we have the cathode side here. And when you apply current to it, it will emitting light. Below are some of the data sheet for this type of 3mm LED, and the symbol part number is TLH4900. So depend on what color. G is green, R is red, and Y is yellow. So we have red, yellow, and green. For application, where do we use this type? It is a started light or it's an indicator of a circuit turn on or off. So those are a few applications. And for the amount of current that they spec here is around 10 mA. Or in this case that they testing it up to 20 mA. And the voltage they measure is 2V, 2.4, and 2.4V. Once again, the forward drop depends on what type of color that you're using. This is the absolute maximum rating of the circuit, the LED. VR stands for reverse voltage, which is 6V. If for any reason you're applying a reverse voltage of more than 6V, you could damage the part. And the IF is the forward current. It is not going any more than 30 mA. Once again, if you apply more than 30 mA, you could damage the components. Let's starting into the LED circuit design. So how do we control the amount of current through it? So we need to use a resistor to control the current through it. So in this case, we have an LED that has a drop voltage of 2.4V. And supposedly we want to use 10 mA to go through this device. So all you need to do is that to define the resistance value, we taking the 5V and we minus with the LED voltage, which is 2.4V. And the total differential voltage will be divided by 10 mA. So the result is 260 ohm for this resistor. So let's start with some simulation for using a symmetrics. to prove that if our circuit is properly designed. So this is my circuit. I'm going to measure the LED voltage, and I also measure the current going through this device. And this is my DC source of 5 volt, and from the previous slides we show that we need a resistor of 260 ohm. So I'm going to run the circuit. Here's your result, and you can see that the bottom one, which is the LED voltage, we have it at 2.4 volt, and associated with that we have a current going through it is 10 milliampere. So look like our circuit is properly designed, and when we go into an actual testing, we should be able to having pretty much similar the same result. So let's get back to our presentation. So the last section I will discuss about some advantage and disadvantage of this type of design. So the advantage is that this is a very simple design. We only need a few components, and it is very cost effective because we don't need to involve with too many components. However, the disadvantage of this type of circuit, so for any reason that if your source, your resistance, your LED voltage change, it will affect the amount of current going through it, and that will affecting the brightness performance of the LED. And another issue is that the efficiency of the circuit, you will creating some power loss in the resistor. So for 10 milliamp, you might lose only 26 milliwatt in the resistor. However, if in some other case that you have an LED that draw 100 milliamp or 300 milliamp, that will creating a lot of power loss in those resistors. So this type of design is not feasible for those. So before I'm ending up this circuit, let me walk you through the LED data sheet of Vishay. Here's the actual data sheet from Vishay. You can download it from the website vishay.com, and they have like 3 different part number here. The TLH4900, and we have green, we have red, and we have yellow. This is the maximum rating, and we also have some detail of electrical. If you want to see the detailed circuit. And down here is some of the characteristic of this LED. One of the important one is this one. You will see that the forward voltage curve compared to the forward current going through it. So the VF is around less than 2 volt if we have up to 10 milliamp. So at 20 milliamp, you will get 2 volt for the red LED. If you're getting more beyond of that, the voltage was shooting up pretty high, and we could damage the part. So make sure that you do not apply anything more than that the manufacturer rating. And this is the end of this section, and thank you for watching it, and I will see you on the next clip.